Let's work on the lift controller system use case specification. Okay, and let's refine it further into version 4. Okay, reach destination floor. This use case allows the lift user to go from a floor to another chosen floor. Preconditions none. Lift user floor sensor. If you remember from our previous sessions, we also now have a door, not door. We have a load sensor. Yes. Then we also have a door open timer, right? These are also devices which interact with our system. Anything else? That's all. So that is the additional actors that are involved. Now let's start with the basic flow. This use case starts when a passenger presses the up down floor button. The system stores the request as a list. The system tells the lift to start. Now, as I was telling you in the previous session as well, that steps are being repeated. So you have the system tells the lift to start, moving lift, open door, removes the request, the passenger gets out into the lift, okay, and tells the door to close. So from door opening till door close is there, and then again the lift starts moving. So again from here to here till the system tells the door to close is being repeated. So what can we do? So let's convert this into a main task kind of thing, right? What shall we name it as? Lift operation. And from here, we will take it up to the system tells the door to close. Okay. And then lift to start, the system tells the okay. So we can stop at this point and remove all this, right? So our main flow becomes only this much. Now the only thing is this lift operation keeps repeating till when? Till current, no, not current, till any more requests. Where is that being checked? Current flow not requested. Pending requests starts at 9. Okay, so let's undo it and see what mm, any more. Here you have more pending requests. So here what we'll do is lift operation till, let's put it in brackets, till more pending requests equal to no. And then till the door closes, we take it, we indent it, and now we can see here the system tells the door to close, the system tells the lift to start, the system tells the lift to start. So from here till here we can remove it off. Yes, the system tells the lift to start, moving left. Now the thing is, while this is happening, while the lift is operating, different people at different floors, they will keep pressing up and down floor buttons. Yes, so we can also say request lift. Name this as request lift, and then let's move these two forward, and let's make this as happens independent of the lift operation, right? So this two steps keep happening independent of what the lift is doing. The only thing is this request list that is being maintained, that will be used here. Yes, request list, request lift, then lift operation. Now when does it stop? Till more pending requests equal to no. And here we are here it repeats till it is Uh, okay, actually it is yes. See, till more pending requests equal to yes, this loop will keep going on. And the use case will end. Again, within brackets, we can say more pending requests equal to no. Okay, so now because we have made changes in the basic flow itself, here we would have used some numbering. This use case continues at 4a, so now we don't have a 4a, so 4a has actually become b1. Now instead of using word numbering for referencing purpose, what we can do is we can use what is called as tags. The use case continues. This flow starts when the response is no for current flow requested at 4c. This was 4 if I'm remembering correctly, and c was this current flow has been requested, right? So this 4c, what we'll do is we will put a tag here. So tag would be let's say requested. So requested at requested. And 4a would be what? Just before reaching a floor, the floor sensor triggers. So floor reached. Let's put a tag like that. So that we can now here say floor reached. So the advantage of using tags is that when we make changes to the specification, word may do some renumbering. So this would not have an impact on the tags. Okay. Now open door timer times out at 8. So where would we time out? After this door open timer has started. At some point, it will time out. So it will happen, the system removes the request, the passenger gets out into the lift. Here, this is where it will happen at 2E while people are going in and out. So here at E, again we use a tag. This is which one? Open door timer. So let's say auto door closer at no, actually this naming would make sense here but not there, so we need to give it a different name. Waiting. Lift is waiting for people to get in or get out at waiting. So here this naming makes sense in both the cases. Okay, the use case continues at 16. So the system tells the door to close. Yes. So G. So this would be, we can say, waited long enough. Yes. So here what will happen? Continues at waited long enough. Similarly, pending request. This flow starts at 9 or 15 when there are no pending requests. Now, pending request is where? Here. Yes, 9 or 15. So what is that? 9 or 50 pending. This is when there are no pending requests. The current floor has been requested. No, not that. Pending requests. Okay, now actually this flow starts when there are no pending requests. Use case continues at 16. That means the use case ends. So here starts at the system tells the lift to start. Here before this, we can just have a check. The system checks whether there are any pending requests. Yes, at the beginning of the looping itself, we can have this. So here we assume that it is yes, there are pending requests. So here it will be no. So which point is this? This is going to be uh, pending. So here at pending, at yeah pending when there are no pending requests. This case use case continues at 16. Now we say 3. So instead of saying 3, we say stop. Here we say stop. Do we really require this pending requests? Because here itself we have shown till more pending requests equal to yes. So if it is no, anyhow it will not go into this and it will come to stop. So this alternate flow itself is not required. So we can remove it. Again, last flow. This flow starts at 10 when the extreme floor has been reached in either direction. Right? So when it is starting, tell the lift to start. So at 2B. So again, uh, start. So here flow starts at start. And the extreme floor has been reached in either direction. The system changes the direction of the lift and then the system tells the lift to start. Or what we can do is put it here, and here we can say the system checks whether it is on the last floor, right? Uh, bottommost or last floor. Yes, this is, and then it starts. The system tells the lift to start. Okay. If it is no, it will just tell the system to start. Moving lift, okay, all that is over. Now let's come to this. Overload. This flow starts at 7 or 14. So when will the load will work? When people are going in and out. So here itself, we can say waiting. While it is waiting for people to get in, get out, it might happen that too many people have entered and the load sensor triggers. Okay. The system resets the door open timer. What is this? When? Okay. Open door. This flow starts at 7 or 4 when the passenger presses the door open button. That is again when it is waiting. Somebody from inside presses that. So while waiting, emergency stop. This flow starts. Uh, okay, we have to mention that as well. This flow starts at waiting. Not necessarily waiting. At any point, a passenger presses the emergency button, or this becomes duplicate. So at any point, the passenger presses the emergency stop button, the system stops the lift immediately, the system sounds the buzzer. And further steps we are yet to decide. Okay. Closed door. Again, this flow starts at, okay, waiting when the passenger presses the closed door button. The flow continues at 10. Now what is this 10? Closed door button means it tells that system will tell the door to close. So after, while the people are getting in and out, a passenger will press that button, tell the door to close. So waited long enough. Although in this particular case the passenger has waited long enough, so we'll say waited long enough. Makes sense. No, it actually is at this point while waiting. Sorry, this will be, yeah, it will be when the people are going in and out. It might happen that one of the passenger presses the closed door button. So waited long enough will not be here. It will be here. No, this is for the timer. Okay. This will be waited long enough. This is okay. This is for the door open timer. And this will be waiting when a passenger presses the close door button. The flow continues at waited long enough. Perfectly fine. Okay. Then what else? Closed door ho gaya. Now to be done. What is this to be done? This is just a explanatory step. Exception flow would be uh, actually, you know what, this emergency stop should be an exception because that is where the whole thing stops. The system stops the lift immediately and the system sounds the buzzer. So that is exception flow. Post condition is the lift is on the last requested floor. Special requirements would be what? This would be very, very interesting to think of. This is really, we can come out with really interesting special requirements. One is the duration of the door open timer must be customizable. That means through some mechanism, we should be able to specify whether it should be for 10 seconds or 15 seconds, door should be open. The speed of the lift movement must be restricted to a customizable figure. Because if you notice, in very tall buildings, the speed will be much faster than the speed of the lift in a hospital. In a hospital, it will be much more slower. Okay, the floors where the lift stops must be customizable. In some buildings, what happens where there will be multiple floors. So what happens is one of the lift will be stopping at all even floors. Another lift will be stopping at odd floors. Maybe one floor goes till the seventh floor and then it goes and stops at every floor. Right. So again, we should be able to customize it, or the user should be able to customize it. When I say the user, I mean the administrator of the lift. Okay, so these have nothing to do with flow of events. Whatever the duration of the door open timer be, the flow remains the same. Whatever be the speed of the lift movement, the flow remains the same. The flows where the lift stops, however you customize it, the flow still remains the same. So anything, any requirement that doesn't impact the flow of events, we put it in special requirements. Okay, now let's just see what word is suggesting. Okay, asking me to remove the comma. Open door timer. Okay, again, comma removal. Ideally, you should remove, make sure at least what word suggests, you check and correct it. Open door. So lift user, floor sensor, load sensor, door open timer. Anything else? Any other sensors that we have? Door open timer, overload, closed door, emergency stop. Okay. So that was our version 4 of the use case specification. That's it. Maybe we will do one more version of this and see whether we can further refine it. That's it for now.